Right, so just moving into working with power questions and slopes as well. So we've got a car of mass 1,100 kilos is travelling with constant speed of 15 metres per second uphill at 7 degrees to the horizontal, and the engine is working at 24 kilowatts. So, drawing a diagram. We have car, we've got normal reaction force, we've got the weight coming down, I'm going to call this a driving force, and then we've also got some resistive forces. So non-gravitational resistance. You can use whatever letters you want here. See, I would be tempted to do F for friction. I'm really not digging these letters. Let's call it a non-gravitational resistance so we don't get too confused. So using power is equal to FV. That's fine if it's on a slope as well. So 24,000 is equal to this driving force times the speed, which is 15, and so the driving force is equal to 1,600 newtons. And then if we resolve parallel to the slope, so we can find this non-gravitational resistive force. Then we've got 1,600 going up the slope. Forces are in equilibrium because it's travelling with a constant speed. And then coming down here, this is 7 degrees, which makes this angle in here 7 degrees. And so this little bit here going down the slope is 1,100 G sine of 7. And then we've also got the non-gravitational resistive force. And then you can pop that into a calculator from there, and you end up with 286.25. That's too accurate because we've used G. And so either 2 or 3 sig fig. So either 286 or 290 newtons. 290 is almost better, I think. Now we're going to increase the rate of work but keep the resistance the same. And for part B, we want to find the initial acceleration. So using power equals FV, where F is the driving force, then the rate of work has increased to 28,000. So remember, power is the rate of work, rate of doing work. So 28,000 is equal to the driving force times 15. So we're just looking for the initial acceleration, and so initially the speed is 15, and that makes the driving force equal to 1,866.7 newtons, which I'm going to keep like that because we don't want to get a rounding error. And then I'm basically coming back into here and using F equals ma. So using F equals ma, we know that from here the non-gravitational resistive force plus this component of the weight that's acting backwards is equal to 1,600. So you don't actually have to do any work with that there. And then we've got the driving force of 1,866.7 newtons acting up the slope. And that's equal to the mass times the acceleration. And then that gives you an acceleration of 0.242 meters per second squared. So if you could go back to that same exercise 2D and look at doing from question 9 onwards. So it's page 32. That'd be great.